everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 140, word break 2. Given a string S and a dictionary of strings word dictionary, as basis in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. Example 1. Input S is cats and dog. Word dictionary contains cat, cats, and sand, dog. The output is cats and dog, cat, sand, dog. So those are all possible or valid break. For the example 2, S equals pineapple, pen, apple. So the word dictionary contains apple, pen, apple, pen, pine, pineapple. Output is pine, apple, pen, apple, pineapple, pen, apple, pine, apple, pen, apple. So this example shows that we can reuse a dictionary word. Let's say involve the breakdown. The pineapple, pen, apple. The apple from the dictionary is reused multiple times. In the example 3, cat, sand, OG, word dictionary cat, dog, sand, and cat. In this case, there is no valid breakdown. Let's say if you are trying to break down at cats, okay, cats, and then you can break down at and, A-N-G, and then the remaining OG is not a valid word in the word dictionary. Similarly, if you want to break down at cat, and then after cat, there is no valid breakdown. Let's say if you break it down to sand, you still left with OG. So in that case, there is no valid breakdown. So how to solve this one? So remember, I had a video for word break 1, and then in that case, we just need to figure out if there's a possible or valid word break. In that case, we solve it utilizing the dynamic programming. But this problem is a little bit different. I mean, it's still trying to break down the words and then trying to match it from the dictionary. But the first difference is, in this word break 2 questions, we can reuse the same word from the dictionary multiple times. Let's say in the example 2, we reuse the apple multiple times. We reuse it twice involve the breakdown. And second, we need to find all possible valid breakdown of this string S and then add it to the results. So that's the two of the difference. So how to solve that? So one idea is to solve it utilizing the depth first search, DFS. So basically it's trying to try different options. Let's say, okay, starting from this one, let's check if C is a valid breakdown. By check if C appears in the dictionary. C is not, CA is not either. CAT, cat, is actually a valid breakdown. So we find one, CAT. And then we check the remaining ones to see if we can break down the remaining ones. So let's say if we have a cursor or pointer points to the start of the substring that we are trying to find the breakdown. Let's say at the very beginning it's start at index 0. We first look at the entire string S, and then we are trying to say, okay, CAT, we find a valid breakdown. In that case, the cursor now is at S. So we just try to look at the substring starting from this position to see if sand, dog can be break down into a valid breakdown. If this can be break down into one, then we find one. How do we know that when to stop? As long as we move the cursor, let's say we utilize the cursor to keep track of the starting of the substring. As long as it moves to the end of this string, then we know that, okay, we successfully find one breakdown and we add that to the result. What if, let's say, we do not have any valid breakdown? Let's say we check CAT as, let's say, if we cannot find something from the word dictionary. So in that case, we just do not add that to the result. So that's kind of the basic idea of solving it using the DFS. So let's start coding. So define DFS. Let me try to first code the DFS. So we have a start index of that's the start index of the substring. And then we also have a path. So let's use something to keep track of the current path. Let's say we need to keep track. Okay, as we are moving the start index, so if we find cat, we need to add this cat to the path to indicate the previous breakdown we already find. So let's the stopping condition. So if start index is greater than or equal to the length of s, so in that case, we can just add the path to the result. So in that case, we need a result as well to keep track of the result. Result.append path. So we know we find one. Okay, if not, which means we are still considering and the index is still within a range. So in that case, for I in start, we check the DFS I. Let's say if S start index I in word dictionary. So I need to do a conversion. So word dictionary equals so I'm trying to convert the input word dictionary from a list to a dictionary. The reason why is if I want to check if any substring is inside this word dictionary, I can using the dictionary, I can just check that in O1 operation. So in that case, if the so what am I trying to do in this line of code? So let's say, okay, for I, let's say, suppose now our start index is here. So, and then we just check, okay, for I equals start index plus 1 until the end of the string. If this substring as start index to I, if that's a valid word in the word dictionary. If it is, then we check that path. So we call it DFSI path. So if that's kind of in the word dictionary, then we move to the new start index. So that's the start index should be I, because we already considered all the substrings up until or before the index I. So then our next starting index is I, and then we add that to the path. So because this substring is a valid word in the word dictionary. So we add that to the path. So to call it, we just start at the index 0, and then initially we call it our we add it to the, we use a list, and then here before I append the path to the results, I'm trying to convert it to the string. So yeah, let's try to run the code. Okay, line 14. Okay, I see. So in that case, let me change this path a little bit. So okay, so let me still using the list. Oh, I got the wrong answer. I know why. I need to return the result. Okay, I still get the wrong answer. Let's say if I move to the length of string -1, okay, I see. For here, I should be at, okay. Okay, this time I get the right answer. Let me try to submit it. Okay, so let me try to walk through the code one more time. So for this one, so basically the idea to solve it is using depth first search. So first, we're backtracking. So here we use as a result to store the output, and then we convert this word dictionary from list to a dictionary, because later if we want to check if a substring is in this word dictionary, uh, to check if it is in a dictionary, we can check within the operation O1. And then we code our DFS function. We choose the starting index of the substring we are considering. And then before that start index, we assume we already find the word break before that start index. And then this path is actually a valid path or breakdown. So for example, here, this one is actually a path. Here I'm using a list to keep track of the breakdowns in this path. And then later, you say if for the stopping condition, if the start index is greater than or equal to the last s, that means I finish checking every characters in this string s, and then I find a valid or break. So in this case, I just append the all the the words breakdowns from this list to the results. And then this one is just to convert that from a list to a string by using the space as a separator. After that, I just return. And then if start index is less than the length of s, it means we still have characters remaining. So we still need to find the breakdown. And then in that case, I check, okay, from the start index +1, so to the length of string +1. So here I made a small mistakes previously about this index, but basically you can think about I as the ending index for the substring we are considering. So the start index is our start index. We want to consider the substrings from the start index to the index I-1. Remember, like in Python, when we trying to slice and index the string up until I, we do not include the character at position I. So here is up to I-1. So that's kind of how we consider every possible breakdowns. So let's say here, when our start index is 0, we consider cat. So that's in that case, the ending position for this substring and at this t. And then we also want to consider possibility for cats. So in that case, that's the ending position at s. So in that case, you probably understand why I utilize the for loop, because I want to consider every possible breakdown from this start index, and then end at different ending index I. And then if it is in the word dictionary, so in that case, I add that substring to the path. And then I update the new start index. After I add that substring to the path, so I start from the starting index of the new substring and then try to see if I can have a valid breakdown. And then this line is just to start at start index 0, and initially we just have an empty list as our path. After that, we return the results.